So what are the approximate bond angles? 1, 2, and 3. So the approximate bond angle 1, 2, and 3. Now, to explain bond angle, we need the geometry of the central atom. And in this case, the central atom is carbon. The central atom here is carbon. So this carbon here is surrounded. The carbon here is surrounded by a single bond, another single bond to nitrogen, and a double bond to another atom. So let's look at the geometry around this carbon atom. You know that carbon has 4 valence electrons. Carbon has 4 valence electrons. And one of the valence electrons is used in a bonding here. Another one is used in a bonding in this place. And 2 of these valence electrons is used up in a bonding here. So all the 4 valence electrons of carbon have been used up. So that means there is no any lone pair surrounding this carbon atom. So the number of lone pair electrons here is 0. The number of lone pair electron is 0 here. Now, then we need to know the number of bonding pair. The number of bonding pair. Now, we have a bond. This is a bond. We have another bond, and we have another bond here. Now, I want you to note that in bonding and in shape of molecules and bond angles, we see multiple bonds as a single bond. What do I mean by that? Every double bond is taken as a single bond. Every triple bond is also taken as a single bond. So the number of bond pair here is 3. The number of bond pair here is 3. So the total number of pairs of electrons, the total numbers of pairs of electrons here is 0 plus 3, which is 3. So these 3, so we only have bond pairs electrons. We only have 3 bond pairs of electrons. So bond pairs of electrons will repel each other evenly. So when they repel each other evenly, so what we have is we have a trigonal planar molecule. And since the total angle in the cycle is 360, if we divide it by 3, since everything is a bond pair, each bond angle will be 120 degree. The 120 degree. So for this, the bond angle here is 120 degree. The bond angle here is 120 degree. So if we come to 2, nitrogen. Nitrogen here is surrounded by 3 atoms. And we know that the valence electrons of nitrogen is 5. Nitrogen has 5 valence electrons. One of these valence electrons is used up in this bonding. Another one is used up in this bonding. And another one is used up in this bonding. So that is left with 2 electrons, which is acting as a lone pair of electrons. So for this, the number of lone pair is equal to 1. Then these are the bond pair. This is a bond pair electron. So this is bonding, bonding, and bonding. As we have it here, bond, bond, bond. So these are bond pair of electrons. So the number of bond pair of electron is 3. So the total we have here is 4. The total we have here is 4. And when we have 4, it's either we have a square planar or we have a tetrahedral. But for this syllabus, we will not consider a square planar under this the AS. So you are only looking at tetrahedral. So the geometry surrounding nitrogen, since its form can be in the form of a tetrahedral. So we have something like this. Now, and we know that the bond angle here is supposed to be 109.5 for tetrahedral. Now, but the geometry of this is not tetrahedral. Why? Because of the presence of this lone pair. Lone pairs are not considered when determining the shape of a molecule. So let's see this as a lone pair. So if we remove this as a lone pair, so what do we have left? What we have left will be this. So we have this. We have this. So this is trigonal pyramidal. Trigonal pyramidal. And for every lone pair that is present in a molecule, you will deduct 2.5 degree, approximately 2.5 degree from the actual bond angle. So the remaining bond angle for this will be 109.5 minus 2.5. So here we have 107 degree. So the bond angle here for 2 is 107. So the bond angle here is 107. The bond angle is 107. So let's discuss 3. Now, if you look at 3 has 4 bonds. Carbon is carbon and surrounded by 4 covalent bond. And we know that that carbon is tetravalency, that is, it has 4 valence electrons. So one carbon is one of these 4 valence electrons is used up here, another one is used here, another one is used here, and another one is used here. So all of its valence electron is used up in bonding. So that means there is no lone pair electron. So the number of lone pair electron here is 0. And the number of bond pair of electron is 4. So the total number of shared electrons, or the total number of electron pair, is 4. So all of these electron pair are used up in bonding. So the geometry around these carbon atoms would be tetrahedral. And we know that tetrahedral is 109.5. So 3 here is 109.5 degree. So for this question 7, 1 is 120, 2 is 107, and 3 is 109.5. 109.5. And that will give us option B. So option B is the right answer for this question. So option B is the right answer. 1 is 120, 2 is 107, and 3 is 109.5.